Hi, it's Trevor Shane from Bosch Home Comfort, here to talk to you about heat pumps in the cold. Maybe you heard that heat pumps don't work very well in the cold, or that they lose capacity and efficiency when it gets very cold outside. But why was that the case? And how did we solve it with our next generation heat pump, the IDS Ultra? Using enhanced vapor injection? I'll give you a warning, it's pretty technical. But don't worry, we have a white paper to help explain in more detail. It helps to know how a heat pump works, and maybe a lot about physics. A heat pump has four major components. The compressor, which is really just a pump that generates pressure to move refrigerant through the system. Pressurizing the refrigerant gas causes its temperature to increase. Next is the condenser coil, which, as the hot refrigerant passes through, will heat the air blowing over it. After that, the refrigerant will be sent to an expansion device, where the pressure will drop dramatically, causing the refrigerant to rapidly cool. Then, the cool refrigerant passes through the evaporator coil, where it will take heat from the air passing over it, causing it to boil or evaporate. Then, it returns to the compressor to start over in this continuous cycle. Where's the problem here? And why is it so hard to get heat when it gets very cold out? So glad you asked. Now this is the hard part, but luckily, I'm not the only smart person here at Bosch. For this, we need the pH diagram, sometimes referred to as a psychometric chart. The pH diagram shows us how the refrigerant changes as it moves through the system. The x-axis is enthalpy. We can think of this kind of like energy. The y-axis is pressure. And this is the pressure the refrigerant sees, and we can measure with our gauges. The hump in the middle is called the vapor dome. To the right of the vapor dome, the refrigerant exists as a gas. To the left, it exists as a liquid. And in the middle, it exists as both, what we call a saturated vapor. When we move from left to right, we're boiling the refrigerant. When we're moving from right to left, the refrigerant is condensing. What's important here is that during the phase change, this is happening at a constant temperature. That's great, but I'm still not seeing the problem here. We can see each of our major components as a side of this trapezoid: our compressor, our condenser, our expansion device, and our evaporator. So, one of the constraints we have is we need the evaporator to always be colder than outside. This means we need to make it drop lower, like this, all while keeping the top the same size, because this is what's keeping you comfortable inside. Now we can see the problem. Remember, we think of the x-axis as energy. So as it gets colder outside, the bottom of the trapezoid is getting shorter. This represents the amount of energy the system is absorbing from outside. So how does IDS Ultra solve this problem? With enhanced vapor injection. What is enhanced vapor injection? Enhanced vapor injection is an add-on to the standard refrigerant cycle. It's like adding a supercharger to an engine. We're going to sacrifice a little bit of energy to gain back more absorption capacity. We're going to start by splitting the refrigerant flow after the condenser. We're going to take this flow and send it through an additional expansion device to a medium pressure and temperature. And now you can see it's cooler than when it left the condenser. Now what we'll do is send this through a plate heat exchanger with the flow from the condenser. This will cause the bypass flow to boil, where we can re-inject it into the compressor at a later stage. Now our main flow will be further cooled. Now, as we send it through our expansion device, it'll be further to the left, allowing it to absorb more heat from outside, increasing our capacity. So it's more difficult to install or requires proprietary controls? No, not at all. Installation is essentially the same as with the IDS Premium. Refrigerant line sets, verify dip switch settings, choose between communicating or standard 24-volt connections, and you can use the BCC 110 thermostat or your thermostat of choice. If you want to learn more, check out our white paper on cold climate heat pumps, link in the description. Or consider signing up for an IDS Ultra factory training here. We have factory trainers nationwide ready to train at your location with live fire equipment.